Hello, students. In the series of learning aptitudes, we learn what is permutations and combinations. Before getting to know about the topic, first we learn what is fundamental counting of principle. In fundamental counting of principle, the first notation we are going to learn is factorial notation. Now, what is this factorial notation? Whenever we have a positive integer n, we denote n with an exclamatory mark. Okay, what is this? N into n minus 1, n minus 2, and it goes on till the number goes to 0. Okay, so here we define 0 factorial as 1 and 4 factorial. Suppose when you have 4 factorial as a number, you will do it as 4 into 3 into 2 into 1, that is equal to 24. Okay, so here we should not ever multiply 4 factorial into 2 factorial is equal to 8 factorial. We should always expand the factorial and then we give the result. We should not directly get into 4 factorial into 5 factorial. Okay, next, the first principle we learn here is addition principle. Whenever we have an event E that is occurring in m ways and we have another event as f which occur in n ways, suppose when these two events cannot occur together, we always do it in E or F ways. That means we will add E plus F. Okay, so next, multiplication principle. Suppose this can be explained using the given example. If Rahul has 3 shirts and 2 pairs of pants in his closet, what are the possible ways of wearing different pairs of pant and shirt? Okay, here these two events, wearing the shirt and pant, is explained here. For every choice of a shirt, okay, whenever for every choice of a shirt he has 2 pants, so there are 6 pairs of shirt and pant. Okay, so this is how we use multiplication principle. Here we have one event as E, another event as F, that is shirt as an event, pant as another event. Okay, so these two M occurs in M different ways, which will have another event in n different ways. Here what we do is total number of occurrence of these events will happen as m into n. This principle is applicable for finite number of events. Okay, whenever we have an event which is known, we can use this type of multiplicative principle. Suppose if we have 3 events, we go with m into n into p. Now, let us move on to permutations. Now we know what is fundamental principles of counting. Next, we'll move on to permutation. Permutation is an arrangement of items in a particular order. Whenever we have a set of alphabets or set of items which can be arranged in a definite order. Here, the important thing is order does matters in permutation. To find the number of permutation of n items, we use fundamental principles of counting or factorial notation which we have learned earlier. Now, permutation, the different arrangements of given number of things by taking some or all at a time. This is called as permutation. For example, we have the letters A, B and C. We are taking 2 at a time here. So there are AB as one arrangement, BA as another, AC as one more arrangement, CA, BC and CB. So here we have 6 arrangements. So how we get this arrangement? Okay, we are taking 2 at a time here. Okay, so next I'll explain this in forthcoming slides. All permutations made with the letters, when you take all the 3 letters, it will be ABC, ACB, BAC, BCA, and this arrangement goes like this. Okay, so this is how we take and arrange when it comes for the letters A, B and C. So here, the number of ways to arrange the letters A, B, C. Number of choices for the first blank. We can have 3, then 2. For the second blank, we have 2 options. And for the third blank, we have only one option. So this number goes in factorial notation. Now what is 3 factorial? 3 factorial is nothing but 3 into 2 into 1. Okay, here ABC are 3 letters which is not going to repeat and we use all at a shot. So this will be 3 factorial, 3 into 2 into 1. So that will be equal to 6. So now this arrangements can be given like this: ABC, ACB, BAC, BCA, CAB and CBA. Now, number of arrangements of n things taken are at a time. Earlier, we have seen permutation where we take n things all together. Now, next one is, so here in this slide, we have learned when we have n arrangements, we are taking all the numbers or all the letters at a time. The next formula which is used for permutation will be learned with this following slide. Number of all permutations of n things taken are at a time. That is, when you have n different things and you just pick up r at a time. So that will be given by this formula npr, that is equal to n factorial by n minus r factorial. Suppose you have 6p2, that means you have 6 items and you're going to pick up 2 items out of it. So this will be 6 into 5 factorial. Okay, so that is equal to 30 factorial. That is equal to 30. It means you have 6 factorial divided by 6 minus 2 factorial. Okay, so that means you will have 6 into 5 as your number. So that is equal to 30. 7p3, that is equal to, you have 7 into 6 into 5. How does it come? In the numerator part, you have 7 factorial, and in the denominator part, you have 7 minus 3 factorial. What is 7 minus 3? That is equal to 4 factorial. So you have 7 factorial divided by 4 factorial. You expand 7 as 7 into 6 into 5 into 4 factorial in the numerator. Denominator, you have 4 factorial. Again, you cancel 4 factorial and 4 factorial, which will give 7 into 6 into 5, that is equal to 210. So, number of all permutation take n things taken all at a time will be equal to n factorial. To find the number of permutations of n items chosen r at a time, you can use the formula npr, which is equal to n factorial by n minus r factorial. Here 0 less than or equal to r, which is less than or equal to n. So this is how we can elaborate the thing. So 5p3 will be equal to 5 factorial by 5 minus 3 factorial, which is equal to 5 factorial by 2 factorial, that is equal to 5 into 4 into 3, that is equal to 60. Okay, let's see an example now. For a college interview, Robert has to choose what to wear from the following 4 slacks, 2 shirts, 2 shoes and 5 ties. How many possible outfits that he can choose from? So now here he have 4 slacks, 4 into 3 into 2 into 5. He can make 120 outfits with what he has. And the permutation goes like this with this arrangement and with this kind of problems. Okay, in the next video we will learn what some more examples how permutations are used and some more important results. Thank you.